Good day, everyone. Our topic for today is all about quantity, lesson 11, part 1. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel. Just select the playlist section. And now let's proceed to our discussion about quantity. The objectives of this lesson is to define quantity, distinguish its relationship to operations, place, value, and fractions, analyze key concepts of quantity, identify and remember the different characteristics of a student's learning from kindergarten through grade 3, and synthesize different strategies in teaching counting from kindergarten through grade 3. The following areas are key points that can be made about quantity in the primary years. Quantity represents the how muchness of a number and is crucial concepts in developing number sense. Understanding the idea of quantity is an important prerequisite to understanding place value, the operations and fractions. An early understanding of quantity helps students estimate and reason with numbers. It is particularly important for understanding relative magnitude, example, few, many, and for proportional reasoning. Example, bigger, smaller, and twice as big or as bigger, half as big. Children learn about the quantitative world long before they enter school. They know which or when something is bigger, smaller, more, less, the same as, and so on. Even toddlers recognize that there is more in a whole cookie than in a half cookie and express their preference. However, having an initial sense of quantity is distinct from being able to count. In time, children make the link between the counting words and the quantities that they represent, but children do not understand intuitively that numbers and quantity are related in many different ways. The quantity of how muchness. As children learn to count, they do not at first recognize that their count of 1, 2, 3, 4, 5 actually corresponds to the quantity of 5 things. Quantity is a complex quality of numbers. The idea that the quantity of 2 apples is the same as the quantity of 2 loaves of breads, and that 1 apple and 1 loaf of bread also represent the concept of two is not necessarily intuitive. Neither is the idea of how such quantitative relationships apply when the units of measure are used. Liters or milliliters of water. Example, 1 liter versus 1 ml. Distance in kilometer nor meter. Example, 1 kilometer versus 1 meter, and so on. The quantity as it relates to understanding operations, place value, and fractions. An understanding of the quantity represented by a number helps students understand the meaning behind an operation. In the operation of addition, the quantities increase as numbers and are added together, and in subtraction, the quantities decrease, making the connection between the increase and decrease in quantity that occurs in an operation is important for making sense of mathematical problems. The concepts of quantity is also important for students' understanding of what is represented in the placement of numerals in a number. The fact that the numeral to the left of any digit in a number represent an increase by the rate of 10, and that the numeral to the right of any digit represents a decrease by the rate of 10 in an important concept of students, especially as they begin to work with larger numbers. It is also has significant implication for their later work with decimals in grade 4 to 6. A sense of quantity is also important as students begin to work with fractions. Students often have difficulty with fractions because they view the two numerals in a fraction such as 2/3 as two separate whole number rather than as a relationship between a part of a quantity and the whole quantity. Quantity, as it relates to estimating and reasoning with numbers, including relative magnitudes, proportional reasoning, and rational numbers. Over time, a sense of quantity becomes crucial in developing estimation skills. A sense of magnitude, a sense of proportion, and an understanding of rational numbers. Estimation skills develop as students become aware of the relationship between quantities. Example, is the amount closer to 10 or to 20? The sense of quantity extends to a sense of magnitude. For example, in recognizing that the magnitude of a quantity is affected by movement. Example, movement on a number line, right or left. More movement on the thermometer, up or down, and cyclic movement as on a clock, clockwise or counterclockwise clockwise. Understanding the inconsistent or the consistent relationship between quantities, example, and doubling as the recipe sets the stage for proportional reasoning, dividing quantities into parts of a whole, providing a concrete introduction of irrational numbers. Understanding quantity. The following information is provided as background information to help teachers increase their understanding of the concept of quantity. We have the following: conservation of number. Piaget worked with young children, revealed a misconception on their part about quantity. Blocks arranged on a table were moved farther away from one another, and the children were asked if the quantity was still the same as it has changed. The children responded that there were now more blocks. They did not understand the conservation of number. That is, that the quantity stays the same even when the items are spread out to look like more, or conversely, that the quantity can be changed only by adding to it or removing from it. Cardinality. When children develop an understanding that the last number of the count of the set of an object actually represents the number of objects in the set, cardinality of a number is what we call. They have begun to understand quantity. No? And see also the counting discussion about this cardinality. Subidize, subitis, sabat, subitizing. Another indication that children are consolidating the concept of quantity is their ability to recognize small quantities without having to count each of the objects. Subitizing or subitizing. For example, knowing that a collection holds 5 bids without having to count them. Dot cards can be helpful in assessing students' ability to subitize or subitize. So dot cards for 5. So these are example of dot cards. Magnitude and quantity. Understanding of quantity is linked to the recognition that movement forward or backward. For example, on a number line, a clock or a scale means an increase or decrease in quantity. Movement along a number line. Let's say 1, 2, 3, 4, 5, and then minus 3. Just move backward, and you will get 2 as your answer. Part whole. Even when young children have developed the capability to count numbers such as 10, they do not necessarily understand that the quantities represented by such number are made up of different parts. In fact, they will often dispute the assertion that 4 counters and 3 counters joined together to make a whole set of 7 counters is the same amount as 2 counters and 5 counters joined together to make another set of 7. Students develop an understanding that a whole, as represented by 7 counters, for example, can be separated into parts consisting, for example, of 3 counters and 4 counters, or 2 counters and 5 counters. Anchors of 5 and 10. Students develop an understanding that numbers such as 2 can be taught of in relation to 5. Example, as 3 less than 5 or a 5 frame. 10 can be a very important anchor for students as it helps them understand many other numbers relationships, remembering the combination that make 10 like 6 plus 4, 7 plus 3, and recognizing that same number can be combination of 10 and another number just like 12 is 10 and 2 or more 13 is 10 plus 3 or more are useful skills for further development of number sense. The composition and composition of number. Students develop quantitative understanding when they begin to recognize that a number such as 25 can be decomposed into two tens and 5 ones or 1 10 and 15 ones or 25 ones. Eventually, students recognize that all numbers can be composed, decomposed, and recomposed. This can help them to understand how the operations, addition, subtraction, multiplication, and division act on numbers. Estimation skills is another one. Estimation skills are related in complex ways to an understanding of quantity. They help students with applying logic and reasoning in problem solving situations. Without estimation skills, students cannot judge the appropriateness of an answer. Students who automatically make a guess of 100 for the number of an object is a large or small container holding many objects do not have strategies for making logical estimates. A related difficulty that students may have is recognizing that if two containers of the same size are filled, one with larger objects and on one with smaller objects, the total number of objects in the container filled with larger objects will be less than the total number of objects in the container filled with smaller objects. Proportions. The concept of quantity is also related to that of proportions, and in particular to the use of proportions in problem solving. Knowing that 3 objects and 4 objects together make 7 objects is information that students can learn to transfer to other kinds of quantities, enabling them to recognize, for example, that 3 liters plus 4 liters makes 7 liters or 3 ml plus 4 ml makes 7 ml. Rational numbers. The concept of quantity is further developed through an understanding of an amount represented by rational numbers. Being able to understand the fraction and decimals as part of the whole is an aspect of understanding the quantity. So that's all about the part 1 of our lesson quantity. In our next video presentation, I will discuss the different characteristics of grade 1 to grade 3 about learning quantity. With that, thank you and good day.